All right, section 3.1, functions. Our objective in this lesson is to determine whether relations are functions, find the domain and range of a function, and identify the independent and dependent variables of a function. Okay, so first we need to talk about what is a relation. A relation, in simplest terms, basically pairs inputs with outputs. So basically what it does is it takes two different sets of data and it pairs one set of data to the other set of data. Okay, so possible relations could be pairing you with your hair color, or your age with your height, or those are some real life examples, but a relation is anything that pairs inputs with the outputs. Okay, so we can list relations as ordered pairs. Okay, if it is an ordered pair, the input is the x coordinate and the output is the y. So if we're listing it as ordered pairs, okay, so if our relation is an ordered pair, we can list it as an ordered pair where we have an x and a y. This first one is the input and this one is the output. Since we can get it as ordered pairs, we can also graph it. They can be graphed. They can be graphed. They also can be written in a table. Okay, and then they also can be written in what we call mapping using two groups. Like this is an example of a mapping one. Okay, so this is showing me that like -1 is my input, it maps, my output's 4. 3 is my input, it maps to 15. 11 is my input, it maps to 15. Okay, all right, so that is just a relation in general. There's no rules on a relation. You just need an input and an output. Whereas a function is a special type of a relation. A function is a relation, okay, that pairs each input with exactly one output. So each input has to be paired with exactly one output. Okay, so each input only has one output. Okay, so for example, the relation of your siblings. Okay, so if I have siblings and I'm saying, okay, Robert would be paired to his brother Jake, but he would also be paired to his brother Eric. So that makes this one not a function because the input of Robert has two separate outputs. Okay, so that relation is not a function. Each input has to be paired with exactly one output. So here, if we want to look to see, determine whether each relation is a function, explain. So we want to look at my inputs. So here I have an input of -2, output of 2, input of -1, output of 2, input of 0, output of 2, 1, 0, 2, 0. Well, if you notice my outputs repeat, like 2, 2, 2, 0, 0, but that's okay as long as my inputs don't repeat because each input can only have one output. So an input of -2, is there any other input of -2? Nope. What about -1? Nope. 0, 1, 2. Yes, so this is a function. Explain. Every input has only one output. Every input can have only one output. The outputs can duplicate, but the inputs can't. Okay, so if we look at this one, here I have an input of 4. 4 goes to 0. Okay, do I have any other? Oh, here 4 goes to 3. So because 4 goes to 0 and 4 goes to 3, I don't even have to look at the rest of these. I know this is not a function. An input of 4 has two different outputs. So if I put in a 4, I don't know what I'm going to get out. Am I going to get the 0 or am I going to get the 3? Okay. All right, so let's go ahead and let's look at this next one. Input of -2, 3, -1, 4, 0, 5, 0. Oh, uh-oh. These two right here have an input of 0, but two separate outputs. So that makes this one not a function either. Not a function. Input of 0 has two different outputs. Okay, so that makes that one not a function. Okay, next one. Input of -1, output of 4. Input of 3, output of 15. Input of 11, output of 15. Well, does every input only go to one output? Every one of these only has one arrow leading through it. So yes, it's a function. Even though both 3 and 11 both go to 15, it is still a function because each input has only exactly one output. So each input, so we'd say yes, it's a function. Each input has only one output. Okay, we're going to do things a little differently. I want you now to pause the video and do these problems. Page 108, 3 through 8. So pause the video, get a separate sheet of paper, and do problems on page 108, 3 through 8. All right, welcome back. I hope those first practice problems went well. Okay. When you're done here, you'll submit and we'll double check and make sure they all went okay. Okay, so after doing those practice problems, we need to answer questions. Are all relations also functions? Okay, do all relations fit this every input has only one output? Well, no. This one, example that we did is a relation. Inputs go to outputs, but it's not a function. So no. Only if every input has only one output. Okay. But are all functions also relations? Well, by definition, a function is a relation. It gives us right there a relation. So yes. Are all functions also relations? Yes. Since it pairs inputs with outputs, it's a relation. Okay, so now we talked about over here that you can graph, since relations are ordered pairs, you can graph them. And we actually have a little trick if we're looking at the graph of a relation to determine whether it's a function or not. Since every input, and your inputs are your x's, so your inputs are here on your x's, and your outputs are here on your y. For an input to only have one output, and the way graphs work with your x's being on, your inputs being on your x-axis and your outputs being on your y, if I draw a vertical line here through any point of my graph, and it only ever hits one spot, then I know that it is a function. We call that the vertical line test, if I can draw a vertical line. So like over here, if I draw this vertical line and it actually hits at two different spots, it hits here and it hits here. So I can tell that this input here, this input, has two separate outputs, this one and this one. So I can tell that it's not a function by that vertical line test. So here, to double check this vertical line test, we're going to go ahead and look at a vertical line going all the way through. If I look at this vertical line, oopsie, I hit two different points. I hit this one and this one. So this tells me it's not a function. And we can just simply say doesn't pass vertical line test. Doesn't pass the vertical line test. Or an input of 2 has two outputs. Okay. But if we look at this one over here, yep, that only hits one spot, that only hits one spot, and so on. If we draw all those vertical lines in, if I just, any vertical line, if I take this vertical line and pass it all the way through here, it's only going to hit one spot. So we'd say, yes, this is a function. Passes the vertical line test. Okay, so again, pause the video and I want you to do these problems, page 108, 9 through 12. So pause the video and do those problems. Okay, welcome back. Hope those practice problems went well. Next, we need to talk about this idea of domain and range. Domain and range is just a shortcut way. Domain is me saying the set of all possible inputs. So instead of me saying, hey, what are all the inputs for this? I would just say, hey, what are the domain? What's the domain? And the range is the set of all possible outputs. Oh, that's not how you spell possible. Of all possible outputs. And since we said earlier, our inputs are my x's, my outputs are my y. My domain is my x and my range is my y. To help keep those straight, domain starts with a D, range starts with an R. Alphabetically, which one comes first? D. Alphabetically, which one comes first between x and y? X. Okay? And range comes next, so that's the y. So if I want to list the domain, I would have to list all possible x's and y's. So if we go back and let's go back here and let's look at one of our functions here. Okay, so back to example 1. Okay, so back to example 1 here. So if I want to list the domain of this guy, the domain I'd list as a set. We do that in curly brackets, and we want to list all my possible x's, all my possible inputs. Well, we've got a -2, a -1, a 0, a 1, and a 2. So I list those out, -2, 0, 1, and 2. There's my domain. Now for my range, I would list all possible outputs. Well, my outputs are 2 and 0. So 0 and 2, I only need to list them once. Those are just my possible outputs. So here's my list of possible inputs, -2, -1, 0, 1, and 2. And my possible outputs are just 0 and 2. Those are the only numbers I can get out. Okay. All right, let's come over here. Let's look at this other function here. There, they give you the domain and range. There's my domain right there. -1, 3, and 11. Here's my range right there. 4 and 15. Okay. Is domain and range. So here, let's find the domain and range of these functions represented by the graph. So now we're looking at the graph. So I think it's going to be easiest here, especially for this graph, this first one, we have ordered pairs. Again, my domain is my inputs. My domain is my x's. So we're going to look at the x's. So what's the x on this guy? So I'm going to come in and I'm listed the ordered pairs. This is the ordered pair, -1, 2, -3, -2. This one is -1, 0, 1, 2. And this one's over 1, 2, 3, up 1, 2, 3, 4, 3, 4. Okay, so my domain is the set of all of the x's. So we've got a -3 for an x, -1, a 1, and a 3. There's my domain. My range. Okay, so again, for my domain, I'm looking at my x's. I'm looking for my, how far left and right does this go? It goes left to -3, -1, 1, and 3. Okay, my range is how far up and down, my y's. So my y's, I go down as low as -2, and then we go to 0, and then 2, and then 4. Okay. Okay. In a connected problem like this, again, for my domain, on this one, we're looking left to right. Okay, so I like to take a highlighter or a Post-it or something and go, okay, how far left does this guy go? It goes all the way over to here, which is what for an x? That's an x of -2. Okay, how far right does it go? How far this way does it go? It goes all the way over here to, what is that, 3? Okay, so it goes from -2 to 3. So I know my x has to be somewhere in between -2 and 3. So using what we know about inequalities, I know my x has to be in between -2 and 3. I can write it that way. Or I could write it in words. X is between -2 and 3. Okay, but we also include -2. Solid dots. There's solid dots here. So we'd need equal signs. And we need to put it in words. We'd say including -2 and 3. So there's the domain. Now for my range, we're going to look it up and down. How far up, how far down? How far up, how far down? So the lowest this guy goes is down here at -1. The highest this guy goes is up here at 1, 2. Okay, so my range again is my y's. So my y's are going to be in between -1 and 2. So we'd write my y in between -1 and 2. We can also include them, so we'd include them. Again, we could write it in words. Y is between -1 and 2, including -1 and 2. Okay, and so now that box that I've made out of that highlighter, my entire graph lies inside that box. Okay, now I want you to pause the video and do page 108, 13 through 16. All right, okay, welcome back. We've got one last bit, and that's talk about independent versus dependent variable. Okay, the independent variable is our input. So usually our x. Our dependent variable is the output, usually our y, okay? And we say it's dependent because our y depends on x. My y depends on what x I put in. Whatever input I pick determines what output I'm going to get, okay? So here in example 4, the function y equals, so here they give us a function as an equation, which a function can be an equation, represents the amount y in fluid ounces. So my y here is the fluid ounces of juice remaining in a bottle after you take x gulps. So x is the number of gulps I take. Gulps you take. Identify the independent and dependent variable. Well, the amount of juice left in the bottle depends on how many gulps I take. So the independent, my independent is x, the number of gulps, and the dependent is y, the amount of juice left. Okay, so if my domain is 0, 1, 2, 3, and 4, what is the range? Again, the range is the output. These are my inputs, so I'm going to have to put those in. So here's my equation, -3x plus 12. I'm going to have to put each of these in. When I put in a 0, okay, when I put in a 0, -3 times 0 plus 12 gets me 12. So I'm going to go ahead and create a table. When I put in a 0, 1, 2, 3, and 4, we get out a 12. When we put in a 1, -3 times 1 plus 12, we get 9. When I put in a 2, we get 6. Okay, -3 times 3 plus 9, we get 3. When we put in a 4, -3, oh, sorry, plus 12. Oop, I messed that one up. These are so big. -3 times 3 plus 12. 9, 10, 11, 12. Yeah, that's still 3. -3 times 4 plus 12. That one's 0. So my range, I would list in an ordered pair at 0, 3, 6, 9, and 12. We normally list the range from least to. Turn to page 108 and do 8.